Hi everyone, this is Doug with Calvert Creative Solutions. So I'm just doing an update video to the Tevo Black Widow 3D printer. As you can see, I've got it built up and running at this point. So just to give you a bit of a scale, on the right I have my Sanoki Prusa i3. It has a 200 by 200 by 180 build area on it. And you can see the Black Widow over here. You can see how much bigger it is. I could almost set my Prusa on the table of the Black Widow. So I was actually very impressed with how the machine went together. I had a few small issues. The largest issue I had was basically these bearings in here. I'm trying to avoid the microphone a little bit. Hopefully you can hear me okay. So these bearings and wheels inside the gantry, I guess you could call it, these carriages, the bolts that go through those little wheels, those ones right there, the bolts are just short enough to clear the back side of the inside of this C channel. However, once you put the M5 lock nut on it, it is no longer short enough. So the M5 lock nuts were actually digging in to the back there, and you can see where I first tried to put the gantry in, I had a lot of issue because I slid it down and then I couldn't raise the gantry anymore. So basically a simple fix for what I did there. Not sure if I can get close enough for you to see. I basically swapped off the lock nuts for standard M5 nuts. Well, it's a little catawampus at this point. But I basically swapped off the lock nuts for the standard M5 nuts, and I put a drip of the blue Loctite on just to keep them from rattling loose over time. And that pulled in the end of that lock nut enough that it could clear with, I'd say, probably about a half a mil of clearance. So it is very tight in there. One problem I have found that, again, in my particular case, is very simple to fix. The hex cam nuts that are in there to actually adjust the offset of the wheels back and forth in the C channel. The hexes are actually too large, so that makes it so basically there's no adjustment because there is only one position that they'll actually fit inside that C channel. That said, in my case, the way the holes were spaced in the plate and everything at the one position that it can clear, it works fine and it's nice and tight in that C groove. So I'm not sure if that was intentional on how they have that or not, but wasn't a problem for me. One other thing in the instructions, it tells you right in here between this bar and that plate you should be putting a copper washer in the 4 screws that come through this side of the plate and tie these together like that. In my case, the length of this bar here and the added length of that bar, the width of this C channel and that bar over there, I didn't need those washers on either side. If I had to put them in, it was binding up the entire gantry. So again, I had to disassemble this gantry from the instructions and actually modify them slightly from what they have. That said, they give you extra washers, so if by happenstance this bar here or those bars coupled with the width of this is too wide, you have extra washers in here to adjust in and out. So again, I think that was probably designed like that to give you some adjustment in the overall length of this gantry. You could take washers out of one side and it would shorten it probably around 3/4 of a mil, or you could stack the washers up and get more and more width if you absolutely needed it. So again, I believe that was in the design process itself, and it seems to make sense, and again, it's running great. So the next thing I will mention is that when I first put this gantry on and let it basically droop down, because at that point I didn't have the Z-screws in, when it came down, it started to wedge itself in between this width. And what I found, once I got this top bar installed, it would come all the way to the top, nice and freely, but as it would get closer and closer to the bottom, it would bind and bind. So what I did, I just loosened off the set screws in that bracket there and that bracket there, which allowed this Z riser to basically bump out, I'd say probably 1/2 a mil, and then I tighten them back down, and now this gantry goes up and down with just, you know, I can just grab this one Z rod, rotate it, and it will pull the belt and everything, and this whole gantry will go up and down nice and easily. So again, I think that's probably by design. What I'm planning to do, I'm going to be ordering some of the L plates for in the corners here, just to help stiffen it up. It is very stiff right now. You can see I'm hitting it right now. There's no noticeable shifting to it, but I am planning on possibly putting a CNC head on this eventually. So I am going to be stiffening this up, probably one here, one there, one down there, one down there. And I'm going to be putting a couple underneath on the bottom of the machine to tie these three pieces together like that. Again, not necessary. You see how it's running right now. It's running very well. So just give you a close-up on the actual part I'm making right now. Hard to catch because it's actually moving at this stage, but it is running really well. One other little edit you may have seen on the bottom of the gantry here, I actually cut the leads off one of the included LED strips and I soldered them together in the center there. So basically I undid the cut that they did, and that LED strip covers the entire bottom of the gantry here. So it gives you a really nice glow the whole width of that gantry. And I also modified the wiring slightly. I'm going to be printing out a bracket here, but right now I have a switch that I can flick my lighting on and off. So you can see that there. Another thing I did, just to clean up wiring a little bit, this Z-axis motor, in the instructions it shows putting it dead center here. I've slid mine all the way over to the side so I could take this wire and basically put it right into the back side of that tower, and it just seems to clean up the printer. And you can see in here the belt in there is completely happy. There's no problems that I've seen with this, and it seems to be running great. One thing I have noticed that I'm somewhat wary of in the near future, and I think I'm going to fix by modifying the cable chain a little bit. You can see the cable chain doesn't necessarily lie straight down. It should be probably down like this here, right? But after a few minutes of printing, it seems to just sort of do a larger arc, which in all circumstances is probably better in the long run anyway, because it relieves some of the strain in that cable. However, if you were to get this gantry all the way up to the top of its axis, there's nothing shielding this belt. So what I'm going to do, I'm going to basically make a couple brackets that are going to bolt in here, come down across, and I'm going to get a piece of plexiglass, I think, and just run it, you know, a few millimeters below this belt. And that's just going to ensure if this did ride all the way up here, that this here is going to ride on the plexiglass and not actually hit the belt itself. You know, worst case scenario is that you keep printing and the Z doesn't lift, in which case it's rubbing the hot end through the material over and over again. So I would really rather, you know, spend a little bit of money and prevent that from ever happening in the future. One other thing, you can sort of see my cobbled together spool holder right now. I had this laying around. I just 3D printed out a basic spool holder that I designed with some bearings in here, and I have my filament sitting in it. And for now, I've got it just running up into the hot end here. What I've designed and I'm going to be printing off, I've got a spool holder that is going to bolt onto this cross member here, and it's going to have a bolt sticking out. Basically, I'm just going to have a 1/2 inch carriage bolt or something sticking out, so it's going to tie right in here. The spool is going to sit on there something like this here. And then what I'm going to have is up here near the top, I'm going to have a bracket either sit right here or possibly off the front, probably flush with this front face. I'm going to have a Bowden fitting and a Bowden tube running up into the end of this hot end right here. And that's just going to give it a nice loop to draw the filament in like this. I've never had a ton of success with this style right now. My custom extruder on my Prusa, you can see it actually draws the filament in the bottom here and up through the Bowden fitting into the head. This works okay because if I have the filament sitting like this on the holder, it's constantly pulling the filament this way, so in this view clockwise. And what this ensures, if this spool holder ever binds up or anything and this decides to basically come out of the spool holder, as this pulls, it unwinds the spool, and because it's going clockwise, it actually makes this spool come away from the machine. So it actually rotates, and like a wheel, it drives away from the machine. This setup here, because the angle of attack is so narrow, even if I were to flip the spool upside down, it tends to pull towards the machine and not pull it away. So I found this setup not to be very good. This is just for testing, and once I have my spool holder on this hand side coming up into the head, I'm going to be a lot more comfortable. One of my main complaints at this point, the control box. I don't know if you can hear that. The power supply fan is very loud. So I'm going to be swapping that out for a 12 volt power supply fan and a 12 volt regulator, something that I know is a little bit quieter. Just because this is, power supply fan is probably twice as loud as actually the printer. In this video, it may sound like there's a lot of high-pitched screeching from the printer itself and the stepper motors, but that I found this particular camera mic is particularly susceptible to that, so take that with a grain of salt. So you can see my very first print on this printer was a basic 40mm cube, right? So I've labeled the sides just so when I go to measure this and try to calibrate, it seems to be working. And out of the box, the X, Y, and Z axes calibrations were dead on. I didn't have to modify those at all. They were within 0.1 mil. However, my extruder, out of the box, the extruder steps per millimeter were set at 610. And from my experience, I've had to up them, I believe, all the way up to 822. Yeah, 822.1. There's lots of videos online on how to calculate this out, but basically what I did, I took a light colored filament, you can see lime green in this case, I fed it into the printer, I took my vernier, and I measured from the face of this little insert up 100 millimeters, right, 100 mil. So with that 100 millimeters, I put a little mark, and I set this here to extrude 100 millimeters. So with that extrusion of 100 millimeters, I found the black mark was still above this insert. So what I did, I measured the difference, I found the ratio, so you get the percentage of filament that needs to be overcome, which it should be a positive number over 1. If you've divided it the wrong way and you have too little filament, you're doing it wrong. And then what you do, you multiply the value in your E-steps by the ratio of how much you have to do, and it should give you a bigger number. Now, this whole process is vice versa if you are extruding too much. But what I think may have happened when they set the 610 in there, the extruder cog may have been a different diameter, and I heard in the Facebook chats here and there, the second batch of printers, they had a different diameter because people were having a bad issue of the filament being ground away. So that may have been what it is, but in my particular printer, I've had to set it to 822.1 to get the proper flow rate through the extruder. So that's a good thing to check if you're having issues that you're not getting enough filament out, or it looks really stringy, or the finish looks funny. So my second print is this. It was just a Thingiverse model. It caught my eye, and I figured, yeah, sure, why not? And you'll see the surface finish on it is all right, but it seems to be better in the X than in the Y. So this is the direction that it would have been sitting on the bed, and you can see the Y-axis as it was going back and forth. You can see there's some ribbing here. That's not Z-wobble. That's the first thing I thought, but it isn't in the X-axis. The X-axis is smooth. So the Y-axis seems to have a bit of a whipping issue at really high feeds. Now, granted, this was printing at 100 millisecond with acceleration rates of, I believe it was set to 2,000. So I've downed the speed a little bit. I believe I'm printing at 65 to 70 right now with an acceleration rate of 1,000. And you can see on this print, any of that Y banding seems to be completely gone. So it just seems like going really quickly with high acceleration settings, just due to the mass of this bed. And this part is actually fairly heavy too. It's 3 shells with 50% infill. I just wanted to give it a worst case torture test overnight, just to see how it was going to run. And it did really well. But this one here, I've slowed it down a little bit. I'm not pushing it too hard. It's still going faster than my i3, but it's doing really well. And at this point, my i3 is about 2 years old, and I have a whole bunch of custom mods on it that I've designed and tinkered with and got it tuned in as best as it can run. Just to give you an idea, that little $200 i3. Yeah, my little $300 i3 is running really well. But this one here, after about 8 hours of printing and maybe 45 minutes of tinkering, I've already got it printing probably 90% as good as my i3 that I've had for 2 years tinkering with. Okay. So that's just an idea of what you're looking at. I would say that the build on this one here is more difficult than something like one of these Lego piece i3s, how the acrylic is all just, keyed together. You can't put it together wrong. This one here, it takes a little bit more finesse and skill to put together. That said, it's not impossible. You don't have to be an engineer to put it together, so I wouldn't worry about that so much. But there she is, the new Calvert Creative Solutions 3D printer. So you can buy these on Calvert Creative Solutions. At this current point, I am the exclusive reseller of the Tevo printers in Canada. So if you're looking to get a really nice large-scale 3D printer for a great value, with all sorts of upgrade capabilities, by all means, go for this machine, because I have not seen any machine run as good as this one has, pretty much straight out of the box. Okay, so thanks for watching. If you have any questions, leave them in the comments down below, and I will be happy to answer anything I can for you guys. If you are interested in a certain video of a certain aspect of this printer, or you'd like to see something, again, by all means, let me know in the comments or personal message me on Facebook, and we can work something out. Okay? Thanks for watching, and have a good day.